doing mesh current method this week. So let's see how it will look like. So in the first week, we discuss about the basic concepts in electrical engineering. So we discuss about the KCL, KVL, current division, voltage division, Ohm's law. So those are the basic things. So last week we discussed about node voltage method. Today we are discussing about the mesh method. So there are other two methods as well, superposition and the source transformation, which we will discuss in the coming weeks. After that, we are applying all this from week 6, I think, 6 or week 5. Okay, so let's see what we do in the mesh current method. It's an application of KVL. If you can remember, node method was an application of KCL, but this one is an application of KVL. The aim is to define simultaneous equations and then find the current. Like it's very similar to the previous one, but we are not considering the currents this time. We are considering the voltages. However, because KVL, we are applying the KVL, but we know voltage is equals to current times the resistance. So we are getting equation in terms of currents. We will find the currents using solving the simultaneous equations. Then we use these currents to find anything, like, we can find the voltage if you want to, depending on what they're asking us in the questions. So let's see. I will come back to this. The steps before that we will do, like, I'll take a simple example and we will come back to the steps after I've explained this. So first thing is, so let's take this as an example. First, we have to identify the meshes. So mesh is a closed loop. It's a loop, but inside the mesh, there can't be any other closed paths. So this is a mesh. This is a mesh, and this is a mesh. But we can't say this as a mesh. Why we can't take the whole thing as a mesh is inside it we have another two meshes. So mesh is a closed path where we have just one loop. We can't have other loops inside the closed path. So we first need to identify how many meshes here. So we have two meshes. Then we assign a mesh current. So this is my first mesh and this is my second mesh. So I assign an I1 current to mesh 1 and an I2 current to mesh 2. So when we do that, we don't have to, like, you can put any direction to the current. However, as a practice, let's take one direction always so that we don't go wrong easily. So we always use to one direction. So I'm using clockwise direction. So let's use clockwise direction. Whenever we have to assign the current, we assign it in the clockwise direction. If in any case, if the question is given the direction of the current, we consider that. Otherwise, if we are putting the direction, let's put towards the clockwise direction so that we always follow the same thing. So first thing is identifying meshes. Second step is assigning currents to meshes. Then apply KVL to all the meshes. So let's apply KVL to mesh 1. So if you apply KVL to mesh 1, KVL says what? When you go around a closed path, algebraic sum of the voltages equals to 0. So I start at a point and I'm going around the mesh 1. So I'm going to a negative 37. We are using the theory that we have learned in week 1. Then we are going towards this. So when we have a resistor, I told you it is consuming energy. So current is in going into the positive side. So this will be a plus 2 times I1. Why 2 times I1? Because voltage is current times the voltage, current times the resistance, sorry. And then we are coming here. If you consider this middle path, we have assigned I1 current to this. And we have assigned I2 current to this side, isn't it? So net current, we are going down now. We are going down, see? So net current in downward direction will be I1 minus I2. Do you agree with me?
Yep.
So this will be plus 12 times I1 minus I2. Then I'm going to 4. 4 is plus 4 times I1 coming back to that start point, and this is equals to 0. So we simplify this. Are you okay with this, what I have done?
Yeah. It just at the start there is meant to be negative 36, not 37.
Yes, sorry. Yes, 36. That's right. Thank you. So now if you write it, you can say 2 plus 12 plus 4 times I1. How did I get it? So I have 2 plus 12 plus 4. And then I have negative 12 times I2, and negative 36 is equals to 0. So I can say 4, 5, 6, 7, 8. 18 I1 minus 12 I2 minus 36 is equals to 0. So we can simplify if you want to make it simpler. So I can say we can divide by 12. Sorry, we can divide by 6. 3I1 minus 2I2 minus 6 is equals to 0. So this is my first equation by applying KVL to mesh 1. Any question up to here?
I think that's pretty straightforward so far.
Okay,
Yeah, I'm
so
all good.
can you do the same thing for the mesh 2? I'll give you a few minutes. How did you go?
I got the first.
Still going.
So when you finish, let me know, okay?
Yeah, I'm all good now.
Okay. So if you did it right, okay, I will do from the beginning, okay? We have shortcuts. I'll tell you the shortcuts later on. Okay, so I'm starting at a point. I'm going to start at this point and going around the direction of the mesh current that I have assigned in clockwise direction. So this will be 9 times I2. It is going to the positive side, plus 24. Then it is going to plus 3I2. And now it is going upward here. So this should be 12 times I2 minus I1. Do you agree?
Yep.
Is equals to 0, isn't it? So what do we get? So if I add all the I2s this time, these 9, 3, and 12. So 12 plus 12 is 24, isn't it? 24 I2 minus 12 I1 plus 24 is equals to 0. We can divide by 12. So 2 I2 minus 1 I1 plus 2 is equals to 0. So is this what you got?
Yep.
Yep.
That's good. So this is really easy. So normally, as I have mentioned as I've told you about the previous one, node voltage method. Here also normally we ask you to get the equations. Okay, so we don't ask you to solve the equations, and we ask you to get the equations and simplify like this. But when you, from your maths knowledge, you know, when you have two simultaneous equations, you can solve it and you can find I1 and I2. I hope you guys are okay with those. Because in the tutorial questions, we need to do that. We need to find, they're asking us to find I1s, I2s like that. But like, you know, in the exams, I will ask only for you to get the equations, because the rest of the things are maths, and this is what you need to know from the electrical.
So are you saying with that then in exam, we only do step 1 of assigning and then step 2 of applying? We don't do step 3 of solving?
Step 4, you don't have to do the step 4.
Okay, yeah.
So first one is the identifying all the meshes. So mesh is a loop which does not contain any other loops. Assign mesh currents, apply KVL, and you need to simplify. Even though you're not doing this, you have to simplify. That means you can't leave like this. You can't leave like this, okay? So you need to do this part. Okay, so that's good. Do you like to solve this? So how do you solve this? Because in the tutorial we are going to solve it. So you can find I1 from the equation 2. So this is my equation 2, this is my equation 1. So I1, if you make the I1 the subject, that will be 2I2 plus 2. So you substitute this in this one. So then we have here. I1 is 3 times I2 plus 2 minus 2I2 minus 6 is equals to 0. So we have 6I2 plus 6 minus 2I2 minus 6 is equals to 0. So you can say 6 minus 2, 4I2 is equals to 0. So I2 is equals to 0, isn't it? So your I1 will be 2 amps. So I1 is 2 amps and I2 is 0. Am I right?
Yeah.
Made it look easy.
So you don't have to, like, in the tutorial we are going to do this, okay? Because we have to get the answer and they're asking us to find it. So we will use that. And also if you are good with determinants, you can put simultaneous equations to determinants and you can find it. And I hope that also covered in your maths. We can try in the tutorial, we'll do something like that to refresh your memory. Okay, so I want you to try this one. They are asking you to find the branch currents in these branches, but don't worry about it. I want you to get the equation for this simple I1 and simple I2. Okay, so I will give you a few minutes for you to write the 2 equations. That's all actually. You are good now. When you finish, let me know, okay? So we can apply KVL to mesh 1 and KVL to mesh 2. How did you go?
Yeah, I got both of those.
Okay.
Except the top one, sorry, I got 3I1 minus 2I2 minus 1, not 15I1.
Yes. At the beginning, I made a mistake in that one. So I forgotten this 10 actually.
No, good.
Yep, that's the same as I got.
Okay. Now let's solve this, okay? Because this is not hard to solve. So we'll solve this. So I can say I1 here is equals to 2I2 minus 1. I'm going to substitute this I1 in the top equation. So when I substitute that one, 3 times 2I2 minus 1 minus 2I2 minus 1 is equals to 0. So 6I2 minus 3 minus 2I2 minus 1 is equals to 0. 4I2 minus 4 is equals to 0. So I2 is 1 amp. So if you substitute that one here, we get 1 amp as well, I1, isn't it? If you know this I1 and I2, simple I1 and simple I2, can you find me the capital I1, I2, I3? You can think and do it. And if you can't, I will help you. Can you find these ones for me, please? So I1 is equals to simple I1, isn't it? That is 1 amp. Do you agree?
Yeah.
And I2 should be simple I2 because that is the current going in this path, isn't it? So I2 is equals to 1 amp as well. How about I3? How do you find the I3? I3 is the net current going down. So you have I1 in the left-hand side and I2 in this way. I2 in the other way around. Count like, you know, according to the arrows. So what should be the I3? Down.
That'd be 0, wouldn't it?
Yes, I1 minus I2, which is equals to 0 amps. So I3 is 0 and I1 is 1 amp and I2 is 1 amp. So that's not hard. Okay, so that's good. Okay, we have few more examples. Okay, in case like, you know, if I ask you to find the voltage here, what voltage here? V naught. How do you find the V naught?
Well, you know the current and you know the ohms, so you can just do the
the resistance, resistance is 4 ohms, and the current going through the resistance is 1 amp. So your V naught will be 4 volts, 1 times 4. Am I right?
Yep.
So when you go to the next questions, that's the only difference. So you have everything as it is. They are asking you to find this voltage. When you find the I2 times 4 kilowatts will be, so kilos you need to convert to ohms. Then that will give you the V naught. So that's the only difference here. If we have time, we will come back and do this. Otherwise, it's the same question, isn't it? Now, if you go to the next one. Okay, now this one I want you to try because you have a current source, bit different. Okay, so I will give you a few minutes for you to write the 2 equations here. Do you have to write 2 equations? You need to think now, okay? Is there any known currents here? You think can do it? I will give you little, few minutes for you to try. Do you know any currents here? Do you know I2? You can't apply KCL to this, KVL to this to mesh 2. Why we can't apply KVL to mesh 2? Because you don't know the voltage. Do we know the voltage here? If it is a voltage source, yes, you know that. But here you don't know the voltage because you don't know the resistance in this one here, isn't it? So we can't apply KVL. Do you agree with me?
Yep.
However, we know I2 because the current going this way is 5 amps, it's given. So I2 is negative 5 amps. Do you agree with that?
Yep. Sure do.
Yep.
Even though we can't apply KVL to mesh 2, we already know I2. So you only need to do the KVL to mesh 1. So when you apply KVL to mesh 1, you start at a point and you go around like in the previous one. So 10, negative 10, 10. So negative 10. Then it is going to 4. So that is 4 times I1 plus 6 times I1 minus I2 is equals to 0. So now you can substitute I2. I2 is equals to negative 5. So negative will become positive. So you can say 10 plus I1, 6I1 plus 6I1 plus 5 times 6 is 30. 30 I2 is equals to 0. So you can say 30, not I2, 30 times 5. 30, no, sorry, 30. Because I2 is already known. So 5 times 6 is 30. 6I2, 4I1. I1. So that will be minus 10 plus 10I1 plus 30 is equals to 0. So we can say I1 is equals to negative 2 amps. Is that right? Did I do any mistakes?
I would believe I did a mistake. I got 4, but negative 4, but I'm sure I did a mistake.
I got 4 originally, and then I forgot that I2 was negative 5, not 5. So, but then I did get negative 2.
Yes. Yes. So because negative, I think you have done the same thing. So you negative will become positive. So this will be a positive 30 and this is a negative 10. So when you get it, like, it will be I10, I1 plus 20 is equals to 0. So I1 is negative 2. So small mistakes will make it wrong. Even I do mistakes. But the thing is, if I do a mistake, I don't lose marks. But you guys, if you do a mistake, you will lose marks. So be careful, okay? And I have you to, like, invigilate me while I am doing. You are saying that if I do something wrong, you find it. But in your case, you will be doing by yourself, and I'm marking it after some time. So you will get. You will lose marks. So be careful. We all do mistakes, but be careful when you do this. Are we good?
Yep, all good.
Yep.
That's good. Okay, so we know that. Okay, here it is the same thing. You assign, we have 3 measures in this case. So this one is I1. You can assign I2. Here you don't have to give I3. You can say this is 30 amps. Okay. So that's already known. So you write the equations in the same way. You simplify it and you can get the 3 equations or 2 equations because we have the mesh 3 current. I will tell you an easy method to do this. So you may have already figured it out. So if you consider this mesh here, I'm going in the clockwise direction. So you can say, without writing many steps, you can say all of these ones. See, there's all, when you add all together, that will be 16, 20. So 25.6 ohms times I1. You can write it like that. And also this 16 is shared between I1 and I2. So that is a negative 16 I2 and negative 5.6 times 30. So this 30 is the I3 or that one there. So this is your negative side. So you can say negative 600 is equals to 0. So you are without having brackets like this. So here you have something like this. This step you can avoid. So did you understand what I did? I added all the resistors, and that will be your I1 because all resistors are common to I1. I1 is going through all 3. But I2, it's a negative because we know the current in the opposite direction, but only 16 is sharing with I2. So negative 16 I2. 5.6 is sharing with the I3. So that is a negative 30 times 5.6. And 600 is entering to the negative side. So it is a negative 600 is equals to 0. Is that clear?
Yeah, that's a good cheat.
Yes. So can you do the same thing to the mesh 2?
I don't see why you couldn't.
I will give you a few minutes for you to try, and then I will write the equation.
Sorry, I thought it was a rhetorical question of whether we could or couldn't.
Oh, no. Okay, I wanted you to try that. So that will be, you add all the resistors, they will be 16, 20, am I right? 20 I2 this time, isn't it? I2 is sharing all of them. I2 is going through all 3. And you have a negative 16 I1 and negative 0.8 times 30 and plus 424 is equals to 0. Is that right?
Yep.
So you have to simplify, okay? So you can't keep like this. So you can add these two together. You know, these ones are just, you don't have I1 or I2. So 424 minus 0.8 times 30, you can put it in the calculator and find it. And you can maybe you can simplify further without having this 20, 16, maybe all can be divided by 4, I think. So you can do that by yourself. So I think we have fine. Okay, now this one has a dependent source. Okay, I want you to try this. Don't solve it, okay? You don't need to solve it, but I want you to write the equation. So KVL to mesh 1, 2, 3. Okay, KVL to mesh 1. So here I note is you have to figure it out. This voltage source is depending on the I node current. I node current is given to us. Which one is I node? I node is the current going upward in this branch. So that is the same current going all the way around. So I node is equals to I3. Do you agree with me?
Yep.
So instead of writing I node, we can use a mesh current to that. So that mesh current I node is equals to I3, isn't it? Is equals to 0. So you can simplify this one. So 10 I2 minus 2 I1 minus 18 I3 is equals to 0. So we can divide by 2. 5 I2 minus I1 minus 9 I3 is equals to 0. So that is our second equation. Did you get that?
Yeah.
You're a bit ahead of me, but yes, I understand.
Okay. Yeah, you take time and do this. We have already covered all the theory. There is one more thing called super mesh. So if when we do it, we are done with whole theory. So this is a different question because we have a dependent source, and please take your time and do by yourself. I will wait.
Just a question on like marking in exams with the equals 0. If you don't put that on the exam, do you get marked down?
Yes, because you that is the law. KVL says algebraic sum of the voltages are equals to 0. If you don't use 0, you are not applying the theory well. And you won't be able to solve the equations, isn't it? It should be equation has two sides.
Yeah, gotcha. I keep forgetting to write it, and then I look back
You
at
need
it, and then
to,
have to go and rewrite it all. Yeah.
yes, yeah. If you don't do it, it is like, not a complete statement.
Yeah, I got it. You'd be good. I've done.
Okay, so we have KVL to mesh 3 as well. So let's do KVL to mesh 3. So start at a point, you can add all the 4, 6, then 18I3 minus 4I1 minus 8I2 is equals to 0. So we can divide all by 4. 4, 4. No, we can't. 2. So 9I3 minus 2I1 minus 4I2 is equal to 0. So we have three equations, three simultaneous equations, three unknowns, I1, I2, I3. We can solve the three equations and find I1, I2, I3. Am I right? Okay. So these are determinants. When we do the tutorial question, we'll do one question like this so that you will refresh your maths. Okay, I want you to get the equations again because this is again it's very similar to the previous one. Yeah. So yeah, this is the last question from this one, and I'll move to the super mesh. Yes. Can you please get the three equations? Yes, three equations. So they haven't given us mesh currents. You assign your mesh current. So this is my mesh 1. It's up to you which one you need to consider as mesh 1. Okay. Let's take all of us the same, all three of us the same I1, I2, I3, so that we get the same equation. Yeah, please write the equations here. I note, here you have I note, that is equals to I3. So this should be I3. So you have everything in I1, I2, I3. And they're asking us to find the power. So power, when you know the resistance and when you find the current using simultaneous equations, you can find the power. So don't worry about finding the power, just find the three equations. How did we go?
Okay, got it.
Okay. How about you, Glenn?
Yep, done.
Okay, so let's see. Did you get these equations?
I obviously put the wrong, I've made those negative, the 27 and the 31.
No, I think we have I1, I2, I3 are different for us. So it's okay. So I2 is I3 in our case. So these are I3s and this is I2. You get what I mean? So let's write it by ourselves. So KVL to mesh 1. So that will be 8, 7, 15, 31. 31 I1 minus 16 I3 minus 7 I2 minus 80 is equals to 0. If you can simplify, you can simplify. Otherwise, leave it like this. So is this right?
That's what I got, yeah.
That's what I got too.
So KVL to mesh 2. So mesh 2, if we say 20, 11, 31 I2 minus 7 I1 minus 4 I3 plus 24 I3 is equals to 0. So I3 you can add. So 31 I2 minus 7 I1 minus plus 20 I3 is equals to 0. So this is the second equation. Is that right?
Yeah, that's where I went wrong. I assigned the 24 as a negative.
Why is that? Because we are coming to the positive side, isn't it? We are going like this, see? The arrow is clockwise. So you're entering to the positive side.
Yeah, that's just a mistake.
Yeah, so be careful with that. Okay, mesh 3. When we write to mesh 3, that
Sorry
will...
to interrupt. I got to duck off to dinner, but thanks for tonight. I'll watch the rest of the recording for the other stuff.
Yeah, that's okay. Yeah, we have just one part left.
Okay, too easy. All right, thank you.
Okay, see you. Okay, so we have 1627 I3 minus 16 I1 minus 4 I2 is equals to 0. So this is the third one. That's good. So we are okay. Yeah, so this is very easy one. You already know I2 is -5. We did this. When they ask you to find the voltage across the 4, that means I1 times 4. I1 you can find using solving the equations, and just I1, the voltage will be I1 times 4. So that can be found. Okay, one more section to cover. So we had a super node when we consider the voltage method. Now, when we consider the current mesh current method, we have to figure out whenever we have a super mesh. Super mesh is where you have a current source sharing with two meshes. So a super mesh result when two meshes have dependent or independent current source in the common as shown in A. So when you have a common current source sharing by meshes, then you know why we need to consider it as a super mesh means because you don't know the voltage here. So whenever you are writing mesh method, you should be able to write the voltage. So you don't know the resistance in this one, so you can't write the voltage. So in that case, when we have, so if you had a current source here, that doesn't matter because see, when you have a current source just for one mesh, you can find it, you know that. But if the current source is shared by two meshes, we don't know the real current here. So in that case, we need to, and also we don't know the resistance. So we have to consider this whole thing as a one mesh. So we consider this as single mesh. So that's what we call the super mesh. So let's do a question, okay? So let's do this. We'll do this question, this one, okay? So we have two meshes here. Left hand side is the mesh 1, second right hand side is the mesh 2. So we assign the mesh currents in the same way, mesh 1, mesh 2, but we apply KVL not to mesh 1, not to mesh 2, we apply to the super mesh. So when you apply to the super mesh, you start at a point, you go around the super mesh. Super mesh means combined mesh. So you are going into the negative side of 20. So negative 20, then you are going to 6. So plus 6 times I1. You are not going towards the down, so you are going this way. So when it comes to the mesh 2, your current is changing to I2. So you have plus 10 times I2. So here plus 4I2. Again, going back to the start point is equals to 0. Did you see what I did? So
Yep. No, that made sense.
okay, so that we get just one equation. So I can solve this and I can say 20, simplify this. 6I1 plus 14I2 is equals to 0. So you can divide by 2. You get 10 plus 3I1 plus 7I2 is equals to 0. So this is my simplified version. We have two unknowns, but we have just one equation. So we should be able to write another one to solve this. Now look at your common path where you have your current source. So how can I write it? So it's like this. So you have a resistor and you have a current source, and this will be 6 amps. 6 amps. And I have I1 going this way and I2 going this way. But the net current going upward is 6. So net current upward is 6. That means I2 minus I1 is 6. Do you agree with that?
Yep. Yeah.
So you have now two equations, don't you?
That's a good sleight of hand.
Yes, so you can solve the two equations and you can solve it. You can find I1 and I2, but we don't going to do that. But now I want you to write the mesh equations for this one. So I want you to write the KVL to mesh 1, sorry, super mesh to mesh. Why we have a mesh super mesh here? Because you have a current source shared by two meshes. It doesn't have to be current source alone. Even if you can have a current source and a resistor. See, here you have a current source and a resistor. Still, if a current source is shared by two meshes, then you need to combine the two meshes and consider it as a super mesh. So here you have a current source shared by two meshes, so you combine it as, consider it as a super mesh. So you can apply KVL to super mesh. So I want you to write the equation there, and also I want to consider this. And I want you to get the second equation. So you have I1 current and I2 current. So consider this one and find one equation. So I'll give you a few minutes. And this is all you have. We are done.
Yeah, I think I've got it.
Okay, that's good. So when you apply KVL, negative 18 plus, you can add these two if you want to, okay, because they are only for I1. So you can say 5I1 minus, sorry, plus 9 plus 6 is 15I2 minus 15 is equals to 0. Is that what you got?
Yeah, I got the same. Yeah.
Okay, so you can simplify. You can say minus 15 minus 18. You can add them to these two. Can be simplified further. Okay, so how did you write the second equation here? This one.
Yeah. Well, I just did 3 equals I2 minus I1.
Okay, so in case if you have downward current, then you need to say I1 minus I2. You got it, right?
Yeah, I think so. Yeah, I think I understand.
Yes, so you are writing the other way around because your arrow is upward here. So that means upward, net current upward is I2 minus I1. It's not the same all the time. It depends on the arrow of the current source. Okay, so here you can see a current source shared by these two meshes and another current source shared by these two meshes. So in that case, you need to consider this whole 3 meshes as a super mesh. Make sense?
Not really, because each mesh is only sharing. Is that right? The two. So,
Yes. Now, like we will, I will redraw this. Okay, so I will redraw this. No, we have another one. Okay, so I will redraw this one. So don't look at this. So if in case if you have like this, so I have 5 amps like this, and I have a resistor, and I have a dependent current source, which is 2I naught, and I have a resistor here and 8 ohms, 10 volts, and okay, so this is what we have. Okay, so we have 4 meshes. Agree?
yes.
So we have one mesh here. I assign a capital I, simple I1 current, and another mesh here. I assign a simple I2, and another mesh here I3, and another mesh here I4, and I naught is negative. I naught is negative I4. Do you agree with that?
Yeah, because it's going in the opposite direction. Is that right?
Yes.
Is that right? Yeah.
So instead of writing 3I naught in this one, 3I naught, I can write it as negative 3I4. Okay, is that right?
Yeah.
So you can see, so we need to find out whether there are super meshes. So if you look at super mesh is what? If you have a current source shared by 2 meshes. If you look at mesh 1 and 2, you can see this is sharing by both the meshes. Am I right?
Yeah.
And also, if you look at mesh 2 and 3, you can see this current source is shared by 2 and 3. Is that right?
Yep.
So, in this case, you can consider this whole thing as a one super mesh. 1, 2, and 3, you can combine it and consider it as a one super mesh. Makes sense?
Yep.
Now you can write the equations. How do you write the equations? So when you write the KVL to the super mesh, you write it in this way. So you can say 6, I'm starting here, okay? So 6 times I2, then I'm going this way. So plus 2 times I1, going this way, coming to here. So that is plus 4 times I3. And I'm going to 8 now. So 8 is shared. Do you see that? 8 times I3 minus I4. Am I right?
Yep.
And coming back to my start point is equals to 0. So this is my equation. You can simplify later. Am I right?
Okay. Yep.
Now you can write the KVL to mesh 4. Mesh 4 is a normal mesh. So KVL to mesh 4, when you write it for mesh 4, you start at a point, go around. So you have 2 times I4 plus 10 and plus 8 times I4 minus I3 is equals to 0, isn't it?
Okay. Yep.
Now we have 2 equations, but we have I1, I2, I3, I4, 4 unknowns. So you need to now look at your shared current sources. So if you look at this one here, you can say I2 minus I1 is 5 amps. Am I right?
Yep. Okay. Yep.
And also if you look at here, maybe we take a different color. So if you look at this one, you can say I2 minus I3 is equals to negative 3I4. Do you agree?
Okay. Yep.
So you have 4 equations now.
You do. Yeah.
4 equations, 4 unknowns. We can solve the 4 equations, 4 simultaneous equations, and find 4 unknowns, isn't it?
Yeah, we're going to have to refresh my mesh
Yes.
equation.
So, yeah. You don't need to solve it, okay? As long as you are confident to get the equations, and if you have the understanding that whenever you have 4 equations, you can solve it and find from your maths knowledge, that's all I need. I want you to write the electrical part. So if you are confident, if you understood how to write the 4 equations here, KVL to 2 meshes, KVL to super mesh, and the KVL to mesh 4, you have to understand why we made all 3 to 1 mesh, because there are 2 shared current sources, and how to write the KVL to super mesh, because when these resistors are shared by different currents, so you need to properly write it. And then the last part is getting these other 2 equations, considering this common parts. I think you are okay with that, because looking at the arrows, you can write the 2 right equations. So as long as you can do that, I don't worry about the maths part, because maths, you passed that subject and came here, even though you've forgotten, you have that knowledge with you. Am I right?
Setting my mind at ease a little bit there, Yupika. Thank you.
Okay. So I hope you understood this.
Yes, I'll go back and obviously practice a heap
You
of
by yourself as well. And there are a lot of other questions we have. You can solve if you want to hear it is solved, and I'm going to put this in views. You can have a look on this one.
Okay.
And the 2 other PowerPoints also there. I think if you want to, you can have a look.
Yeah, I was just doing the second one this afternoon.
Okay. This is the same thing. We have few more questions. If you have time, we can go through. Otherwise, if you want to practice by yourself and do it in the tutorial, it's up to you. So they all now the theory is covered. We need to practice. That's
What are we doing next week? Next lesson, Yupika?
Next, you mean this Wednesday or next week?
Wednesday.
Wednesday we do the questions in the 2 exercises part.
Okay, I'll just go and practice some then, and then I have some questions for Wednesday. Is that?
Yeah, that's fine. And also, I think some of the questions are already here. We are anyway doing them on Wednesday as well.
Okay, great. Yeah, that'd be good.
Okay. Okay, so if you have any question, just drop me an email. Yeah.
I will. Thank you very much.
Okay, so we'll see you on Wednesday.
Thanks, Yupika. See you Wednesday.
Bye.